In today's class, I'm going to show you quick tricks that will help you to determine if a chemical reaction is an oxidation reduction reaction, simply called redox reaction. So the first reaction, we have Cu plus 2Ag plus going into Cu2 plus 2Ag. Okay. Every element in its natural or pure state has an oxidation number of 0. So we are going to look at the oxidation numbers of these elements. Copper is in its original or pure state. So copper will have oxidation number of 0. The oxidation number for copper has now jumped up to 2 on the right hand side. This tells you that copper has undergone oxidation. Silver plus has an oxidation number of +1. On the right hand side, silver has an oxidation number of 0. This tells you that silver has undergone reduction. So this reaction is a redox reaction. Okay, so that's one way of telling if a reaction is a redox reaction or not. What if I don't want to use the oxidation numbers to tell if a reaction is a redox reaction? Another trick that you can use is that, for example, in this reaction, C2H5OH plus O2 giving you carbon dioxide and water. Oxygen is in its pure form on the left-hand side. If you find the same pure element inside of a compound, that reaction is a redox reaction. The next reaction, we have ACl reacting with sodium hydroxide to give you sodium chloride and water. Notice that we don't have any pure element on either side that is found inside of a compound on both sides. All of these are compounds. They are not pure element that is found inside of a compound. So this reaction is not a redox reaction. Reacting acid and a base to form salt and water is a classical example of a neutralization reaction. The next one is similar to the first one that we had. Okay, so we have a reaction, aqueous iodine reacting with aqueous bromine to form aqueous iodine and aqueous bromide ion. So iodine on the left hand side has an oxidation number of -1. Okay, on the right hand side is 0. This tells you that iodine has undergone oxidation. Br2 is a pure element, so it has an oxidation state of 0. On the right hand side, it has an oxidating state of -1, meaning bromine has undergone reduction. So clearly, there are changes in the oxidation numbers of these atoms. So this is a redox reaction. The next one is a decomposition reaction, where we have mercuric oxide, AgO, decomposing to form Ag plus O2. Okay. Again, the trick is that notice that we have pure element. Oxygen is in its pure element, O2. And oxygen on the right hand side is found inside the AgO compound on the left hand side. This tells me that this reaction is a redox reaction without even going through the oxidation numbers. Okay, that's a very quick trick. The last one, we have silver nitrate reacting with sodium chloride to give you silver chloride solid and sodium carbonate. In this reaction, we do not have any pure element that is found inside of a compound on either side of the equation. So this reaction is not a redox reaction. In fact, this reaction is a classical example of what we call precipitation reaction. For a quick recap, today's class, we have looked at how to quickly identify if a certain chemical reaction falls under redox reaction or not. And we saw that redox reaction involves moving electrons from one atom to another atom. So if an atom loses electrons, it becomes oxidized. If an atom gains electron, it becomes reduced. So if the oxidation numbers goes up, that will be an oxidation. If the oxidation numbers go down, it becomes reduction, and that reaction will be a redox reaction. We also saw a cool trick that if you find the same element on one side of the equation and that same element is found inside of a compound in the other side of the equation, that reaction becomes a redox reaction. Thank you so much again for spending time with us. And please remember to subscribe to KokoChem Education YouTube channel, like, share, donate so that we'll be able to make more amazing videos to help you in your academic journey. And see you next time. Bye.
Think, learn, become